Have you ever wondered just how cold or hot the universe can get? To comprehend this, we first need to understand the concept of temperature. Temperature is essentially the measure of the average kinetic energy of the particles in a system. In other words, it's a way to gauge how much stuff is moving around. Now let's zoom out and apply this to the universe as a whole. The universe is a vast, complex system, with particles ranging from the blazing hearts of stars to the frigid voids between galaxies. Amidst this cosmic dance, there's a limit to how cold things can get. This lower boundary is known as absolute zero, sitting at a chilly negative 273.15 degrees Celsius. At this temperature, particles theoretically stop moving completely. So we have a clear bottom limit for temperature, but what about the other end of the scale? Is there a maximum temperature? Absolute zero, a chilly negative 273.15 degrees Celsius, is more than just a low number on a scale. It's a fascinating concept in the world of physics, representing the ultimate cold, the point where all molecular motion stops. Imagine, if you will, a world so cold that even the atoms are frozen in place. That's the essence of absolute zero, but why can't we reach it? The third law of thermodynamics answers this. It states that the entropy, or disorder, of a perfect crystal at absolute zero is exactly equal to zero. In layman's terms, this means that everything would be perfectly ordered with no room for any energy transfer. In our universe, such a state of perfect order is impossible to achieve, making absolute zero an unattainable goal. However, this doesn't make absolute zero any less useful. In fact, it serves as the basis for the Kelvin scale, a temperature scale widely used in science. Named after Lord Kelvin, this scale starts at absolute zero, eliminating negative temperatures entirely. Each unit on the Kelvin scale is equivalent to a degree on the Celsius scale, making it a straightforward conversion. Reaching absolute zero may be impossible, but science has gotten incredibly close. However, the same can't be said for a maximum temperature. While there is a definite floor for temperature, the ceiling is a different story. When it comes to heat, there's no clear cutoff point, no upper limit that we know of. This concept may seem perplexing, but it's all part of the fascinating world of thermodynamics. Now you might be thinking, isn't there a maximum temperature? Indeed, scientists have proposed a theoretical upper limit known as the Planck temperature. This is a mind-bogglingly high measure of heat, approximately 100 billion degrees. Beyond this point, our current understanding of physics becomes, well, less than useful. The Planck temperature is named after Max Planck, the physicist who first proposed quantum theory. It represents the highest theoretically possible temperature, a point where the very concepts of space and time become fuzzy. But where in the universe could such extreme temperatures exist? The answer takes us back to the very beginning, to the Big Bang. In those first fleeting moments of existence, temperatures might have soared to levels near the Planck temperature. The universe was an incredibly hot, dense point where all the laws of physics as we know them were essentially irrelevant. Yet despite these theoretical extremes, the concept of a maximum temperature remains highly speculative. There's still so much we don't know about the universe and its laws. So while we have a clear minimum temperature, the maximum is still a hot topic of debate. So what have we learned about the universe's thermometer? We've delved into the icy concept of absolute zero, sitting at a chilly negative 273.15 degrees Celsius. This is the lowest possible temperature where all molecular motion ceases, but it's a limit we can approach yet never reach. It's like the ultimate tease of the cosmos. We've also explored the other end of the thermometer, the realm of infinite heat. Unlike the cold limit, the universe doesn't put a cap on how hot things can get. It's a cosmic free-for-all where temperatures can skyrocket indefinitely. However, we did touch on the Planck temperature, a theoretical high-temperature limit based on quantum physics. But remember, it's not a hard limit, just a point beyond which our current theories break down. The universe is a fascinating place, isn't it? Full of extremes from the absolute zero to potentially infinite temperatures. Keep wondering, keep exploring, and remember, science is always heating up.